I'm going to talk about how to generate random variables in Excel following a specific distribution. So look at this example. There's a vending machine which holds 40 items. The daily demand from this machine follows a specific distribution specified over here. The question is, how long does it take on average to sell out all of those 40 items? So look at the daily demand distribution here. The demand could be 0, 1, 2, 3, 4, or 5 with those corresponding probabilities. Conceptually, how do we generate simulated daily demand following this distribution? Look at this graph. Let me explain it here. So we have a line between 0 and 1. And this line is broken into 6 buckets. Each bucket represents a simulated demand. It ranges from 0 all the way to 5. And the width of each bucket is exactly the probability of that demand. For example, the probability of 0 demand is 0.1, so the length of this bucket is 0.1. The chance of having 1 demand is 0.15, so the length is 0.15, so on and so forth. And here, each mark is the so-called cumulative demand, which is simply the total of probabilities up to this point. For example, here 0.1 is simply this probability. 0.25 is the sum of these two numbers. 0.45 is the sum of these three numbers. With that, how do we generate simulation? Well, what we do is this. We draw a number between 0 and 1. Imagine you have a box with any numbers between 0 and 1 with equally likelihood. You pick one ball, and let's say turns out to be 0.34. And 0.34 happens to be between these two numbers. So you conclude that the simulated demand is 2. And for now, another example, let's say you draw a number, it says 0.56. Turns out that this number is in this bucket, so you conclude that the simulated demand is 3. Okay, now let's see how we can take this concept to generate simulation in Excel. So I have the probability data, the same graph, and now I'm going to generate simulation over here. I'm going to generate simulation by day. Day 1, day 2, day 3, so on and so forth. I'm going to generate the demand for those days. But first, I need to draw a number between 0 and 1. And here's a function to do that. It's called rand, R-A-N-D. So rand will give you a number between 0 and 1. For example, it now gives me 0.04. By looking at this figure, I know that, well, it falls in the first bucket. So the simulated demand should be 0. So it should be 0 here. But how can we tell Excel how to look up this thing? Well, you need to use a function called VLOOKUP. And you need to generate a table for that function to look up. Here's a table. There are 2 columns here, and there are 6 rows representing 6 possible outcomes. The first column is the minimum of each bucket. So remember, here are the 6 buckets. The minimum refers to, for example, for the first bucket, the slowest number in the cumulative probability that goes into this bucket. So it's 0. For the second bucket, which is demand of 1, the minimum of that bucket is 0.1. For the third bucket, demand of 2, the minimum is 0.2. So on and so forth. And a more convenient way would be probably this, equal to this number, and you just drag it down. Okay, we have the minimum for every bucket now. And this is just the corresponding demand, which is those numbers. So I'm going to copy and paste them over here. Now this is a table ready for lookup. So here's the function we're going to use. Equal to VLOOKUP. It asks for 4 parameters. The first parameter is the number to look up, which is the random number, because we're going to look up this number from this figure, in other words, this table. Lookup value, and the table you want Excel to refer to, which is this one. So I'm going to select the entire table. Do not select the labels. Also, I'm going to put $signs so that I will fix the reference. Third input is the column index. So it is the number of the column you want Excel to return from this table once it finishes the lookup activity. In this table, we want Excel to return the corresponding demand. So demand is in the second column, so we enter 2 here. Last column, please choose true here in this case, because otherwise you will get an error, because Excel will look for the exact value in this table in the first column, 0.757, which is not here, then you will get an error. So please use true over here. Okay, for example, now the random variable is 0.78 which is here, so the simulated demand is 4, so that's correct. The last column, I'm going to store the total demand up to this day. So I'm going to equal to, this is the first day, so it simply equals to the demand on that day. For the second day, I can do the same. Well, first, generating a random number. Well, I'm going to use the same VLOOKUP table. So I drag down the cell. You can check the formula is correct. It still refers to the same table because I fixed the reference. But now total demand is different. It's demand today plus demand, total demand up to yesterday. Okay. Then I can keep doing that and drag down the cell. I can then further drag them down as long as I like. For example, now I have 36 days of simulation, and the total demand apparently exceed 40 in the end. So how do I find out the number of days I run out of inventory, which is actually in this case 16? How do I store this here? So here's a little trick. Here's a little trick I'm going to do. I'm going to show only the day when the total demand up to that day is less or equal to 40. So I'm going to do this. If the total demand is less than 40, then I'm going to show this day, which is the previous day plus 1. Otherwise, I'm going to leave it blank. If you want to leave it blank, you do this in Excel. Okay, now let me recopy this all the way down. Okay, you see, for this simulation outcome, I'm going to run out on day 17. Now let me press F9. I have another simulation outcome which I'll run out on day 40 on day 23. So now I can store the days to sell up here, which is simply how do I know which day it is? It will be simply the maximum number in this column, right? Okay, so I'm going to do this equal to max of those entire column. Okay, for example, day 18 in this case. All right, that's good. So this is the outcome of one simulation run. It tells me that in this run, it takes 18 days. Now let me press F9. It gives me another simulation outcome, which says day 20. Next time, it gives me 15. Next time, 14. So you see, this is simulation. There's randomness. So the outcome changes every time. So how can I answer the question, how many days does it take on average to sell out the inventory? Well, apparently you need to conduct simulation for many times and take average. How do you do that? Well, there's a smart way to do that. It's using something called data table. So how do we use data table? Yeah. Okay, let's say we are going to simulate for 20 runs. Remember, this is just one run of simulation. This run of simulation says 19 days. We're going to generate 20 runs of simulation. And you can generate, usually you generate more runs. I'm using 20 quite arbitrarily just to show you how to generate many simulation runs. You probably need to generate more and much more than 20 runs. Okay, so this is a simulation run, 1 through 20. For each run, I need to store this number. Okay, I want to store the days to sell for every run. So how do we do that? Okay, so here's how you set up data table. Equal to 18, equal to this cell. What it means is that I want Excel to fill in those cells with the number that comes from this cell. So what do I do next? So next, I'm going to select this whole thing. The first column is always the index column, and remember to include this top row over here. Go to data, what if analysis, data table. Here in the column input cell, you just click on any empty cell, any cell that does not contain anything in Excel. So what does that mean? Well, column input cells means that, well, where do you want to input those numbers into the model? We don't. These are simply indexed. They are not input to the model at all. So you click on any empty cell, which means that Excel later on will input those numbers, replacing those numbers into this cell, which doesn't do anything, which is what we want. Okay, and then click on OK. Now we have the simulation run. So it runs 20 runs of simulation. For the first run, it says 16 days, second run 18 days, so on and so forth. Now we can calculate the average days to sell out. Okay, the average number of days to sell inventory out of those 20 runs of simulation is simply average of these 20 numbers. Okay, so now I'm going to press F9. Still, every time I press F9, a new outcome comes up, but you can see the randomness in this number is much smaller than the randomness over here. So this number is a better estimate of the average. In fact, if you take the average out of more runs than 20, you'll probably find this number to have a smaller variation. And that's how you generate many simulation runs.